Hello. In this movie, we're gonna study section 7.2, screening model of settlement. In the previous section, in section 7.1, we studied a very basic model of settlement. And in that model, a problem is, well, in model of settlement in section 7.1, this was a very basic model. Here, we could explain why litigants settle with each other very often. So in that model, we saw that all cases are settled. So in this model, we saw that all cases are settled and no case goes to trial eventually. So using this basic model, we could explain why in reality, very often times litigants settle with each other. But problem is, in this very basic model, there was no trial. So all cases are settled before litigants go to trial and they stand before a judge. So in this model, trial never happens, and this is not realistic because in reality, many cases are settled, but still a few cases go to trial and litigants stand in front of judges. So we want a better model of settlement to explain this reality. So in reality, we want to explain coexistence of settlement and trial. So in a better model of settlement, we want to explain some cases are settled, but some cases go to trial. This is what we want, and this is what we're gonna do in section 7.2. The key point in section 7.2 is asymmetric information. So asymmetric information is the key in this section, and by introducing asymmetric information to the model, we can explain settlement and trial both exist in the model. So what is asymmetric information? If you remember previous section 7.1, in the basic model of settlement, all information was known to everyone. So both plaintiff and defendant know everything. So they have every relevant information. So for example, think about expected judgment. So think about expected judgment at trial. So think about this expected judgment at trial. So for example, X is equal to 100. It means that, for example, plaintiff and defendant expect $100 million at trial. So if defendant loses, defendant has to pay $100 million to plaintiff. And if plaintiff loses at trial, then nothing happens. So the stake at trial is 100 in this case. And both plaintiff and defendant know that 100 is at stake at trial. So in this case, we don't have asymmetric information. And in this case, we say information is symmetric. So when we say symmetric information, it means that all parties know every relevant information. But in section 7.2, now we introduce asymmetric information. And in particular, we're gonna introduce asymmetric information through expected judgment. So we're gonna assume someone knows what X is, but others do not know. And this asymmetric information is the key in explaining the coexistence of settlement and trial in this model. So let's study together. Now let's assume X is either small or big. So you can imagine that XL is, for example, $1 million and XH is $100 million. So expected judgment at trial is either $1 million or $100 million. So if expected judgment is $1 million, the stake at trial is relatively small. So defendant lose, then defendant has to pay $1 million to plaintiff. But if X is equal to 100, then now there is a really big stake at trial. So if defendant plaintiff go to trial eventually and defendant loses, then defendant has to pay $100 million to plaintiff. So this is a really big amount of money. And now there is some asymmetric information regarding expected judgment. So let's suppose plaintiff knows. So plaintiff knows X. So this means plaintiff knows whether expected judgment X is equal to 1 or 100. So plaintiff knows the exact value of X. But defendant does not know. So defendant does not know X. Instead, defendant only knows that X is equal to small number with probability 1 minus P, and X is a big number with probability P. So dependent knows something, but dependent does not know very precise information. So plaintiff has precise information. So if X is equal to 1, plaintiff knows that X is equal to 1, but dependent only knows that X is equal to 1 with probability 1 minus P, and X is equal to 100 with probability P. So dependent only knows probabilities, so dependent does not have precise information about X. So in this sense, we say there is asymmetric information between plaintiff and defendant, and this asymmetric information is about expected judgment. In this kind of situation, let's see what's going to happen eventually, and we're going to see that eventually some cases are settled and others go to trial. So let's assume defendant is going to propose a settlement. So defendant is going to propose a settlement offer S, and let's assume this is the last chance for settlement. So if plaintiff rejects, then they go to trial tomorrow. So today they have last chance to settle with each other, and defendant has this last chance to make a settlement offer. And this is rejected by plaintiff, they go to trial tomorrow. So let's think about this situation. Then here our question is how much is defendant going to offer? So how much is defendant going to offer in this case? And what's going to be the response of plaintiff? Does plaintiff accept or reject? So we're going to think about this here. Suppose suppose defendant propose a really big amount of settlement. Suppose defendant is going to offer a really big amount. So that means defendant is going to say he's going to give a lot of money to plaintiff, and plaintiff accept, then they don't go to trial. Obviously, if defendant offers a lot of money, plaintiff is gonna accept. Then what do I mean by a lot of money? To be precise, suppose defendant is going to propose a settlement offer S, and suppose S is bigger than this blue quantity. In this case, what's gonna be response of plaintiff? So let's think about plaintiff's point of view. So remember, when defendant make a proposal, defendant does not know whether X is low or high. Defendant only knows that X is high with probability P and low with probability 1 minus P. But plaintiff knows what X is exactly. So defendant offered S, and suppose plaintiff knows that X is equal to XL. So in this case, plaintiff knows that X is equal to XL. So it means plaintiff knows that when he goes to trial and wins, he can get only small amount of money from defendant. And in this case, defendant is proposing a lot of money for settlement, then obviously plaintiff has to accept. So let's make this more precise. In this case, if plaintiff accept settlement, then plaintiff's payoff is equal to S. Because they have settlement opportunity today. So if plaintiff accept, then defendant is gonna pay S dollars to plaintiff today. So plaintiff's payoff is gonna be S. If plaintiff reject this settlement offer, what's gonna happen? Now they have no more opportunity for settlement today. So plaintiff is gonna go to trial tomorrow. So when plaintiff goes to trial tomorrow, he's gonna get X dollars from dependent. So he expects to get X dollars from dependent. And here plaintiff knows that X is equal to XL. And at trial, plaintiff has to pay litigation cost CP. So when plaintiff reject, plaintiff expect to get XL minus CP tomorrow. And we cannot compare these two directly because they are expressed in different time period. So we have to calculate present value. So we're gonna calculate present value by multiplying delta. Then now we can compare these two. So today when defendant makes a settlement offer, plaintiff is going to compare red and blue. And in this case, plaintiff is going to accept because here, as you can see, S is bigger than delta times XH minus CP. And delta times XL minus CP is smaller because XL is smaller than XH. Therefore, accepting settlement S is better than having delta times XL minus CP. Therefore, plaintiff is going to accept. So here, in this blue line, it means that if plaintiff knows that he expects to get small amount of money at trial, plaintiff is gonna accept. What if plaintiff knows that X is a big amount of money? So in this case, defendant is proposing a lot of money, and plaintiff knows that he can get a lot of money at trial. Then what is he going to do in this case? If we accept, then defendant is going to pay S dollars today to plaintiff. So plaintiff's payoff is S dollars. If plaintiff reject, then they go to trial tomorrow. Then trial tomorrow, plaintiff is going to get XH minus CP at trial. And because this is value of tomorrow, we can calculate present value by multiplying delta. So plaintiff, when he knows that X is equal to XH, he's gonna compare red and blue, and we can see that red is bigger. So plaintiff is going to accept. So this is the precise meaning of what's going to happen if defendant propose a lot of money. So in this case, defendant's proposal of settlement is really big. So plaintiff is going to accept regardless of his information. If plaintiff knows that he expects to get small amount, then he's going to accept. If plaintiff expects to get a lot of money at trial, he still accepts the settlement. So in this case, we always have settlement. And when you think about this, logic, make sure you have XL here, XH here, and try to fully understand why we have XL in the first law but XH in the second law. Okay, so in number one situation, defendant's proposal was too big. What if defendant's proposal is slightly lower? So for example, S is exactly equal to delta times XH minus CP. So think about situation number 2. So in this exercise, we are trying to think about what is the best for dependent. So obviously in number 1, it seems that dependent is offering too much settlement money. So maybe this is not the best for dependent. So what if dependent is going to propose slightly lower amount? So for example, think about second situation. So in the second situation, settlement offer is exactly equal to delta times XH minus CP. And by now you can see that this purple expression is present value. This is present value of plaintiff's trial payoff when X is equal to XH. So in this case, now what if X is equal to XL? So what if plaintiff knows that he's gonna get small amount of money at trial? If plaintiff accepts settlement, he's gonna get S dollars today. If plaintiff rejects, then he goes to trial tomorrow and he expects to get XL and he has to pay litigation cost. And again, make sure we have XL here because plaintiff knows that X is equal to XL. And let's calculate present value. So we multiply delta. So we're gonna compare which one is better for plaintiff, accept or reject. And we can see that accept is better because S is bigger than this value under rejection. So if plaintiff knows that X is small, then he's gonna accept. What if plaintiff knows that X is XH? In this case, if plaintiff accept, he's gonna get $S today. If he reject, he goes to trial tomorrow, and he's gonna get this much payoff tomorrow. And again, make sure we have XH here because plaintiff knows that X is equal to XH. And this is tomorrow's value, so we multiply delta and we compare these two options. So accept is better or reject is better. It turns out that these two are the same in the second situation. So plaintiff is indifferent between settlement and trial. So in this case, let's assume plaintiff is gonna accept. So in this course, let's assume if someone is indifferent between settlement and trial, he's gonna choose to settle. So again, in this case, plaintiff is gonna accept. So what's happening here? In the second situation, dependent is offering a slightly lower amount than in situation number 1, and plaintiff still always accept. Then it must be situation number 2 is better for dependent than situation number 1 because in situation so if you compare this green and blue, dependent is offering more settlement money under green because in green expression we can see that settlement offer S is bigger than delta times XH minus CP. But in blue expression, settlement offer is exactly equal to delta times XH minus CP. So in the second case, dependent is offering smaller amount. And if you look at situation number 1 and number 2, plaintiff's decision is the same. Plaintiff accept when he knows that X is small, and plaintiff also accept when he knows that X is big. So plaintiff choice is the same. Plaintiff always accept. So in this case, we can see that second situation is better. So in other words, if dependent offers settlement S exactly equal to delta times XH minus CP, this is better than when dependent offers settlement bigger than delta times XH minus CP. So here we can see that dependent is better off by offering S exactly equal to this expression than by offering S bigger than this expression. But maybe we can do better than situation number 2. So let's think about what's going to happen if dependent lowers his settlement offer. So now, suppose what if dependent settlement offer is lower than this expression, but it is bigger than this expression. So now by now you can see that this red expression is present value of plaintiff's trial payoff when X is big, and blue expression is present value of plaintiff's trial payoff when X is small. So in third situation, we want to see what's going to happen if dependence offer is between these two expressions. So let's think about this. So when plaintiff sees this kind of settlement offer, what is he going to do? What if plaintiff knows that X is small? So what if plaintiff knows that X is small? In this case, if he accepts, he's gonna get $S today. So plaintiff's payoff is equal to S. If plaintiff reject, what's gonna happen? They go to trial tomorrow, and plaintiff obtain this much payoff tomorrow. So this is plaintiff's trial payoff tomorrow, and this is tomorrow's value. So we calculate present value by multiplying delta. Then now plaintiff is going to compare these two expressions, and we can see that S is bigger because from this inequality. So S is bigger, we can see that from this inequality. Therefore, plaintiff is going to accept. So in other words, if plaintiff knows that X is small, then he's going to accept. What if plaintiff knows X is a big number? In this case, if plaintiff accepts, he's gonna get $S today. If he rejects, they go to trial tomorrow, and plaintiff obtain this much payoff at trial tomorrow. So this is plaintiff's trial payoff tomorrow. We can calculate present value by multiplying delta. Now plaintiff is going to compare these two, and we can see that this expression is now bigger than S because of this inequality. So plaintiff is going to reject. So in this case, if plaintiff knows that he's gonna get a lot of money at trial, then in this case he has incentive to reject dependent settlement offer. So in this case, if dependent settlement offer is kind of intermediate, then plaintiff is going to accept only when X is small. Otherwise, he's gonna reject and they go to trial. And so in this case, let's think about dependence expected cost. So when dependents make settlement offer, what is dependence expected cost in this case? So we can see that dependent is gonna pay $S if X is small, and probability of this is 1 minus P. So why? Because here we know that litigants settle only when X is equal to XL. So in this case, dependent is going to pay $S to plaintiff and they don't go to trial. So if X is equal to XL, plaintiff is going to accept. So dependent has to pay $S. If X is equal to XH and probability of this is P, so here I'm talking about probability because from dependent's point of view, dependent does not know whether X is small or big. Dependent only knows probability. So if X is big number, then dependent is gonna pay, if X is a big number, so X is equal to XH, we know that, as you can see here, plaintiff is gonna reject. So in this case, dependent is gonna go to trial tomorrow. So dependent is gonna go to trial tomorrow, and he's gonna pay XH to plaintiff, and he also pays litigation cost to CD. And make sure we have XH here because X is equal to XH in this second line. And this is dependence trial payoff tomorrow. So we can calculate present value by multiplying delta. So here, what do we find? When dependents offer intermediate amount of settlement offer, dependent is gonna pay, so dependent's cost is S with probability 1 minus P, and dependent's cost is this expression with probability P. Therefore, dependent's expected cost is 1 minus P times S plus probability P times this expression. So our conclusion here is if dependent offers intermediate amount, dependent's expected cost is this green expression. So why do we calculate dependent's expected cost? Because we are trying to find best offer for dependent. Why do we think about best offer for dependent? Because this is dependent's decision making. So here at this point, dependent is gonna offer settlement amount $S. So dependent is gonna offer $S to minimize his expected cost. So we are trying to find the dependent's expected cost, and we're gonna compare them, and we're gonna see that dependent is gonna offer S with the smallest expected cost. Okay, in number 4, what if dependent's offer is further down? So what if dependent offer is smaller? So as you can see here, think about this is a possible settlement offer. So first, we thought about this case. So this is number 1. And number 2 was what if dependent offers exactly this number? This was number 2. Number 3 was what if dependent offers a settlement amount in this green range? So in number 4, we're gonna think about what if. So this was number 3. And number 4, what if what's gonna happen if dependent offers exactly this value here? So here in this process, we are think about all possible settlement offer, and dependent is gonna choose the best offer for himself. And here, best offer means the offer that generates the smallest amount of expected cost for dependent. So number 4, what if settlement offer is exactly equal to this expression? So in the face of this kind of offer, what is plaintiff going to do? If plaintiff knows that x is small, what is he going to do? If we accept, he's gonna get $S today right away from dependent. And we know that S is equal to this expression. So if plaintiff knows that X is a small number, by accepting this settlement offer, he's gonna get this much payoff today. If plaintiff reject, they're gonna go to trial tomorrow, and plaintiff obtain this much trial payoff tomorrow. This is trial payoff tomorrow, so we can calculate present value by multiplying delta, and plaintiff is gonna compare these two, and they are the same. So we can see that plaintiff is indifferent between settlement and trial, and let's assume plaintiff is going to accept. What if plaintiff knows that X is a big number? If we accept, he's gonna get $S today right away. So S is equal to delta times XL minus CP. If plaintiff reject, then litigants go to trial tomorrow, and plaintiff obtains this much payoff tomorrow. And present value is this expression. So if you compare these two, second expression is bigger, so plaintiff is going to reject. So in number 4, plaintiff's choice or plaintiff's decision is exactly the same as in situation number 3. So if you compare number 4 and number 3, plaintiff's decision is the same. So plaintiff is going to accept if X is small, and plaintiff is gonna reject when X is big. So plaintiff's decision is the same, but what's the difference between number 4 and number 3? Dependent is offering smaller amount in number 4. Therefore, we can see that in number 4, dependent is better off. So in other words, offering intermediate amount is bad relative to offering exactly this number 4 amount. So what we know, if you compare number 1 and number 2, I said number 2 is better than number 1. So as long as dependent is rational, he's gonna offer number 2 instead of number 1. And if you compare number 3 and number 4, we can see that number 4 is better than number 3. So as long as dependent is rational, he's gonna offer number 4 instead of number 3. So this means dependent is not going to offer S in this number 3 range, and dependent is not going to offer S in this number 1 range. And finally, let's think about this blue range. Then we are done about thinking about all possible settlement offer. So number 5. What if now settlement offer is really small? So now you can imagine that this settlement offer is too small. So plaintiff is gonna reject even when plaintiff expects to get small amount at trial. So let's see. So what is plaintiff going to do? If plaintiff knows that X is small, so is it better to accept or is it better to reject? If plaintiff accept, then he's gonna get S dollars today from dependent and they don't go to trial. If plaintiff reject, then litigants go to trial tomorrow and plaintiff obtains this much payoff tomorrow. We can calculate present value by multiplying delta. And if you compare these two, we can see the second expression is bigger. So plaintiff is gonna reject. What if plaintiff knows that X is a big number? So what if plaintiff knows that X is a big number? If we accept, he's gonna get S dollars today and they don't go to trial. If plaintiff reject, they go to trial tomorrow and plaintiff obtains this much payoff tomorrow. So present value, so multiply delta. And if you compare these two, we can see the second expression is bigger, so plaintiff is going to reject. So in this case, settlement offer is too small. So in this case, plaintiff is going to reject all the time. So plaintiff is going to reject all the time. So even when plaintiff expect to get very small amount at trial, even in that case, he's gonna reject. So in this case, they always go to trial. Then in this case, what is dependence expected cost? So in this case, what is dependence expected cost? So when dependent offers very small amount of settlement offer, dependent knows that it's gonna be 100% reject. So dependent knows that he goes to trial. So dependent goes to trial, then what's gonna happen? Dependent is gonna get, so dependent has to pay this much money at trial if x is small and probability is 1 minus p, and dependent has to pay this much. So here, this is CD, dependence litigation cost. And dependent has to pay this much money at trial if x is a big number. And probability of this situation is P. So again, remember, I'm talking about probability because dependent does not know whether x is small or big. Only plaintiff knows it. So dependent does not know whether x is small or big. So dependent only knows that he has to pay this much money with probability 1 minus p, and he has to pay this much money with probability p. And we can calculate present value by multiplying delta. So dependence expected cost is 1 minus p times this expression plus probability p times this expression. So if you compare, so in number 5, dependence expected cost is this expression. And in number 4, so if you calculate expected cost in number 4, it's gonna be lower than number 5. So let's see. So in number 4, what is dependence expected cost? So let me do calculation here. So in number 4, so remember settlement dependent offers this much in number 4. So dependent offers this much in number 4, and we know that, so let's think about dependence expected cost. So dependent is gonna settle. So dependent can settle if x is small and probability is 1 minus p. And we know that plaintiff is going to reject if x is big number. And in this case, dependent goes to trial, and dependent has to pay this much money at trial. And make sure xh here, because we are thinking about the case x is equal to xh. So present value multiply delta. So this means in number 4, dependent So dependent expect to pay S with probability 1 minus P, and dependent expect to pay this much money with probability P. And S is equal to this expression. So dependence expected cost is 1 minus P times settlement plus probability P times this expression. So this purple expression is dependence expected cost in number 4. This green expression is dependence expected cost in number 5. If you compare these two expressions, the second part is the same. So if you compare, this part is different. So green expression is bigger than purple expression. So this means number 4 generates lower cost for dependent. So now we can summarize our finding up to here. So what is our finding up to here? We are thinking about all possible settlement offer. And two numbers are important here. One is delta times XL minus CP. So this is present value of plaintiff's trial payoff when X is small. And second number is delta times XH minus CP. And this is present value. This is present value of plaintiff's trial payoff when X is a big number. We saw that. So this green area is number 1, and this point is number 2. And we saw that number 2 is better than number 1 in the sense that by offering exactly this much settlement offer, dependent expect to pay lower cost than offering some settlement offer in range number 1. So offering any amount in number 1 range is bad compared to offering exactly number 2. So we don't have to worry about what's gonna happen if dependent offers some amount in this blue range. We don't have to worry about that because number 2 option is better than number 1 option. And second, we compare number 3 and number 4. So in other words, what if dependent offers exactly number 4? Is it better than offering any amount in number 3 range? And the answer is yes. So offering number 4 is strictly better than offering any amount in number 3. So that's what we saw. So we don't have to worry about what if dependent offers some amount in number 3 range. We don't have to worry about that. And finally, we thought about number 5. We thought about green range, number 5. We thought about green range, and we just saw that number 4 is better than number 5. So dependent is not gonna offer number 5. Now then our conclusion is so dependent wants to minimize his expected cost. So to minimize his expected cost, dependent is going to offer either number 2 or number 4. So that means dependent is going to offer exactly this offer or exactly this offer. So dependent is going to compare number 2 and number 4, and he's going to choose one offer that generates lower expected cost. Okay, so we can say this is a high offer. So let's say this is SH, high offer. And green is low offer, so we can say SL. Because if you compare SH and SL, SH is bigger. So when dependent offers SH, dependent is offering more money than when he offers SL. So here, dependent is wondering, should I offer SH or SL? Which option is better for me? So he has to think about this. And as we saw before, if dependent offers SH, we saw that plaintiff always accept. So plaintiff accept when X is small, plaintiff accept when X is big. So plaintiff always accept. So in this case, dependence cost is just settlement money. And settlement money S is equal to this expression. So if dependent offers SH, dependence expected cost is this expression. What if dependent offers lower offer SL? So in this case, we saw that plaintiff accept only when X is small. So plaintiff accept only when X is small. So in other words, so you can look at the dependence expected cost expression in number 4. So this purple expression over here. So this purple expression over here is dependence expected cost when he offers exactly this value. So if dependent offers a smaller offer, dependence expected cost is so this is dependence expected cost. So now what dependent has to do finally is compare red and blue. So if dependent offers a relatively big amount, then his cost is red. And if dependent offers relatively small amount, then he's gonna get blue. So dependent is going to compare these two, and if red is smaller, then dependent is gonna offer relatively big amount, SH, and if blue is smaller, then dependent is going to offer relatively smaller amount, SL. So let's say this is red and this is blue. So dependent is going to offer SH if red expression is lower than blue expression. And otherwise, he's going to offer SL if red expression is bigger. So you can put equality sign to any of these two lines, but let's forget about equality sign here. So let's look at this inequality. So let's calculate this inequality. So write down red expression and blue expression and think about this inequality. And you can simplify this inequality. So write down this inequality using red and blue expression and simplify this inequality. Then we get this inequality. We can see that this red expression is a sum number between 0 and 1. So this is bigger than 0 because numerator is positive and denominator is positive, so bigger than 0. And this red expression is lower than number 1 because denominator is bigger. So let's say this is so think about this expression. So our previous conclusion was dependent is going to offer SH if probability P is bigger than this red expression. Otherwise, he's going to offer smaller amount. So what is the meaning of this? What is the meaning of this line? So here we can provide interpretation of what this means. So look at this inequality. So remember P, what is P? P is the probability that X is a big number. So P is the probability that dependent has to pay a lot of money at trial. So this inequality means the probability that dependent has to pay a lot of money at trial is really big. So this inequality means P is bigger than something. So maybe P is very close to 1. So this inequality means the probability or the chance that dependent has to pay a lot of money at trial is really big. So in this case, so remember dependent does not know exactly whether X is big or small. So dependent only knows probability. So in this case, plaintiff thinks that it is highly likely that he has to pay a lot of money at trial. Then of course, dependent is going to be afraid of going to trial. So if possible, dependent wants to settle with plaintiff. Therefore, dependent is offering big amount. But in this case, as you can see, probability is very small. So probability is lower than something. So probability may be very close to 0. So what does it mean? The chance or the probability that dependent has to pay a lot of money at trial is very small. So it is unlikely that dependent has to pay a lot of money at trial. Then in this case, dependent is not that worried about going to trial. Therefore, dependent is offering a smaller amount. But as you can see, still dependent does not want to offer all the way to 0 because SL is some positive number. Because by offering SL, at least he can have a settlement with the lowest possible case for plaintiff. So in this case, remember if possible, it is better for dependent to settle. So because as we saw in the previous section, we saw that it is better for both litigants. To settle rather than going to trial. So that's why in the previous section, in basic model of settlement, litigants always settle without going to trial. But here in this section, sometimes they go to trial because dependent does not know what X is exactly. So it is not easy for dependent to find the right price or the right amount of settlement. So when dependent calculation of the right amount of settlement is not that good, maybe it is rejected by plaintiff, so they go to trial. But other times they can settle. So because if possible, still settlement is better for both litigants. In this case, as you can see, even when probability P is very small, dependent does not offer 0. So does not offer close to 0. So at the minimum, dependent is willing to offer SL dollars. Okay, so we saw that now, so we can see that probability is crucial here. So if dependent thinks that it is highly likely that he has to pay a lot of money at trial, then he's going to offer a lot of money. So in this case, they always settle, and there is no trial. So we can say in this case, we have full settlement. So we have full settlement result. So in this case, dependent is afraid of going to trial because of the high likelihood of paying a lot of money. So he's going to offer a lot of money at settlement. So they always settle and they don't go to trial. But in this case, dependent is not that afraid of going to trial because dependent thinks that it is unlikely that he's going to pay a lot of money. So he's going to offer a small amount. So in this case, dependent settle if X is small. So when dependent offers SL dollars, plaintiff is going to accept if X is small. So plaintiff knows that he's going to get small amount at trial anyway. So in this case, plaintiff says, okay, in this case, I'm going to just accept and I don't want to go to trial. And this offer is going to be rejected and they go to trial otherwise. So plaintiff knows that he can get a lot of money at trial, then he doesn't want to accept this kind of low settlement amount. So plaintiff is going to reject. So in this case, they go to trial. So in this case, we obtain partial settlement result. So as you can see, dependence probability, what dependent thinks about the chance and likelihood is now really important. So if probability is big, we have full settlement, so there is no trial, and this result is similar to our basic model of settlement result. But in this case, so now dependent is not that afraid of going to trial. In this case, we have partial settlement result, and we can see that we have both settlement and trial. So sometimes dependent and plaintiff can settle with each other, and sometimes negotiation breaks down and they go to trial. So in this case, we can see that, so you can say that this is small claim case. So this is small case, this is big case. So what do I mean? So for example, XL is 1 million and XH is 100 million. Then if X is equal to XL, the stake at trial is small, so we can say this is a small case. But if X is equal to XH, really big stake is at trial, so we can say this is a big case. So this small case, so in this case, if X is small, so the story is there is a car accident, and plaintiff pretends that his injury is serious, but if X is in fact X is small, it means that even when plaintiff acts like injury is serious, in fact injury is not that serious. So when they go to trial, dependent expect to pay very small amount. But otherwise, in this case, plaintiff pretends that injury is serious, and in fact injury is serious. So in this case, when they go to trial, dependent has to pay a lot of money. And we can see that big cases go to trial. So we can see that big cases go to trial in this case. So small cases are settled, and small cases don't go to trial, and big cases go to trial. And this result seems realistic because if you look at newspaper and TV, sometimes we have sometimes we have plaintiff and defendant, they fight at the court in front of the judge, and oftentimes those cases involve really big damage and injury. So for example, think about the fighting between two big companies. And so oftentimes we observe this kind of big case at TV and newspaper. So it seems that big cases going to trial and small cases are settled and they never go to trial. This result seems quite realistic. Okay, so using this model, we can see that we can explain coexistence of settlement and trial. And remember, the key here was asymmetric information. So the key here is asymmetric information. So in the basic model of settlement, we had symmetric information. So both litigants, plaintiff and defendant, they know all relevant information. But here in this model, screening model of settlement, now we have asymmetric information. So Plaintiff knows the exact value of expected judgment, but defendant does not know it. Defendant only knows the probabilities. So in this way, we introduce asymmetric information to the model, and it turns out we could explain settlement and trial at the same time, and we can obtain quite realistic result. So from this exercise, you can see that as you introduce more complexity to the model can explain reality much better. But trade-off is the model can explain reality much better, but instead the model becomes more complex to analyze. Okay, so we thought about screening model in this section.